Okay, we want to now cover stationing and profiles. You use these a lot in either road work or utility work, a lot of times in land development. So let's just get into it. What is stationing? Stationing is nothing more than an accounting system. If we zoom in, we have a starting point and we have an ending point. That's as simple as it gets. Now, in between, we call stations, and a station is nothing more than 100 feet. So for this example, which is this example showing a new sanitary sewer line, happens to be, I believe, a 16-inch. Notice that it's bolded. We want to show what is existing and what is new work in a clear manner. In this case, we have sorry, my mouse is lagging a little bit. We have existing work. We have new work. Notice the contrast. Notice that the new work really comes off of the page. We do that so it's easy to see and not confused with other items. Down in the lower area, there's a lot of existing utility lines, and if we didn't distinguish between what was new and what was existing, then we would have readability issues and mass confusion. So getting back to the topic at hand, and that is stationing. So the two things that we said a stationing was really an accounting system, and also has a start and end point. This is a good example of why we use stationing systems. We couldn't start from basically our high side, and when I say our high side, we all know that water flows downhill. So this is the point that is the highest on the job site, and this is the lowest point. This is a pump station. So we really can't account for it in a linear fashion. So in other words, if we started from the high end along this line here, it got to the finish point, we would be pretty far off, because this is a much shorter line than the actual bold installation that we require. So how do we accomplish determining where the certain segments of it are located? And well, let's ask why we need to know where particular things are located. Well, for one, we have manholes that are along the route. For instance, here. In here. We also have different taps, things that are coming in that we want to know exactly where those items are. Without giving a point, we could, give a geolocation point, COGO point for short, just as we've done with this box here, 101, 102, 103, and 104. We have to tell the reader where this particular item is located. The way we do that is stationing. So there's a known distance between station 000, and stationing usually starts with 000. So I want to quantify that. Why would it be usually? Well, there can be multiple stations along a project. For example, if you have city streets, you have a sewer network, many other applications, you have T's and joints and intersection points. It may not be convenient to always start at 0, 0, 0. You may start and run one section from 0 to 5 plus 0, 0, and then start again with 1,000 or so forth. But when I say usually. So how do you read these? You may be a little bit ahead in your civil career, but you at least know how to read these. So you may or may not have covered this in survey. You probably have, but this is station 1 plus 23. So how is it written? It's written STA 1 plus 23. So that is the mark here. Okay, so again, this is nothing more than an accounting system. I can't stress it enough. A lot of people don't understand the fundamental concept of stationing, and that becomes an issue. So if we start from this location here, which we have defined as 0, 0, 0, and we travel 23 feet to the next location, that is one particular run. And we've defined this here. We've given some information. Station 0, 0, 0 is the existing pump station, and the next manhole we call a conflict manhole is at station 23. So this distance here is 23 feet. Okay, it's at an angle, so we can't, again, as we discussed a couple minutes ago, we can't measure directly because this is a system that essentially makes a curve. Okay, the next run is from station 23, 0 plus 23 to station 0 plus 76. So essentially we're looking at this run here. We've defined the location to be station 0 plus 76, and that's a new manhole. And so we go on down the line. So we have the next run here, the next run here, next run here. Notice that they're building off of each particular station before it. Now, you know, this application is a sanitary sewer line, and we need to transmit a little bit more information along with it. The top half of this sheet is a plan view, how we want the network installed, what the connections are, what the locations are, and below it we have tied it to a profile sheet. In other words, this is a section cut. That's the easiest way to say it, is a section cut. Now, carrying on with our stationing concept, again, this is user defined. We've decided where that the project starts and ends. So we chose to start at the sanitary sewer lift station, and again we chose 0, station 0 plus 0, 0, and the reason we did that was because we only have one run on this project. We're reiterating the 23 linear feet of 16-inch and the grade here. So in other words, the entire system is working its way uphill. notice on our profile that we've listed some inverts. And just to reiterate, went too far. We have a benchmark with an elevation here that's listed as 103.17. So that's what we're measuring against, is that nail in a power pole. Just in case you're curious, that PP is a surveyed nail that was installed in a power pole at that elevation of 103.17. So we listed the invert here. And what is an invert? The invert is the flow line of a pipe. That's the very bottom of the pipe, not the bottom of the outside, but the bottom of the inside. As we go along, we've listed additional inverts. And these should be listed for each manhole. It gives a double check. So we've got the distance and the slope on each one. We show these as a manhole. And from there, the contractor can lay the pipe. So this end, the flow line of the pipe, not the bottom, but the flow line would be at 90.78, and the high end would be at 90.99, 53 feet of pipe. Last thing, and then we'll catch it on another video. This is the existing grade. This tells the contractor roughly how deep he needs to install it. So these are relative to the project. So we have an elevation of 100 and an elevation of 90. So we have roughly about 10 feet, a little bit less than 10 feet of dirt on top of this pipe, actually from the bottom of the pipe. So the contractor can tell how much to install there.